Let's take a look at an example that's a little bit tougher. I want to use laws of logs to write this expression as a single logarithm again and simplify if possible. In this first example, you might be looking at it and say, well, I only see one log, so this is kind of weird. I don't know how to add 3 to this log. And as it stands, we can't right now. I do know that I can use the power property and rewrite this as log of 3 squared, but then I still have this plus 3 strangeness. But if you remember that this is the exponent, like all these things, since we're in log land, think of them as exponents. I want to convert this 3 into some sort of a log where 3 is the exponent. So what I mean by that is if I think back, this is my log base 10 of something should equal 3. So another way of saying this is 10 to the what power equals 3. 10 to the third power equals what? And that what is 1,000. So really I could rewrite this as log base 10 of 3 squared plus log of 1,000. Since 3 is equal to log of 1,000. And again, that conversion, I'm thinking 10 to the third equals what? This is how I get my log. So now that I have that squared away, I have log of the product 3 squared times 1,000. And I guess I could take this a little bit further. I could say this is equal to the log of, this would be 9 times 1,000, so this is the log of 9,000. So all of that mushed into one log looks like this. All right, let's take a look at this example. A little trickier still. Now you might think, oh, well, I have this quotient, so I could just subtract 8 minus 4, but no, be careful. This is not the same. I am not taking a quotient of my inputs, but these are the quotient of 2 logs. So I need to treat this a little bit differently. So what I would do is, at first it doesn't really look like I know what I need to do with this, so when in doubt, just play around with it, see how you can rewrite things. I know that I can rewrite log of 8 as the log of 2 cubed, since 2 to the third power is equal to 8. Which means that I can rewrite this as 3 times the log of 2. Okay, so that's just a different way of looking at this. These are equivalent. And then let's take a look at log of 4. Log of 4, that's the same thing as log of 2 squared. And that's going to equal 2 times the log of 2. And hey, what do you know? Now I have like a fraction. This is all going to equal 3 log of 2 over 2 log of 2. And since these logs are just like numbers, I'm multiplying 3 times log of 2, multiplying 2 times log of 2. These are common factors, the log of 2, numerator and denominator. So those actually cancel, they reduce, and this whole thing just equals 3 over 2. And you could type that into your calculator, check. On its own, these are pretty ugly numbers, log of 8, log of 4, but when you divide them, you get these nice, this nice fraction, 3 halves. So why don't you try a couple examples like this, a little bit tougher, pause the video, and see what you can make out of them combining these things together. All right, and here are my answers. Here's the working out for all this. And once again, converting something into a log from a whole number, you just have to think about your exponential. And this is going to be your exponent. All right, so let's take a look at another example where I have something a little bit different. I'm given now p is equal to log base b of 2, q is equal to log base b of 3, and r is equal to log base b of 5, and I want to write all these things in terms of p, q, and r. So this is a little bit strange. This is a problem where we have to kind of think kind of creatively. And really what this is asking me to do is, since I'm given 2s and 3s and 5s as my inputs for these values, for these logs, what I'm basically trying to do is make 6 look like it's using 2s and 3s and 5s. So I kind of want to like dissect the number 6 until I'm using components that involve 2 and 3 and 5. So here's what I mean by that. I know I can write this 6 as 2 times 3, since 2 times 3 is 6. And now, since I have a log of a product, I can use that log identity or log property. This becomes log base b of 2 plus log base b of 3. And wait a second, now I know what log base b of 2 is. That's p. So this is going to equal p plus log base b of 3 is q. So this is all equal to p plus q. Let's take a look at another example. And this one might be a little bit simpler in some ways and more difficult in others. Because now I'm already looking at a 5 and a 2 and a 3, but now I've got this pesky square root to handle. So let's rewrite this log base b of I'm going to actually rewrite this square root of 3 a different way. This is going to be 5 times 3 to the 1/2 power divided by 2. So now what I can do is I can split all this up using my log properties. So this is going to equal log base b of, well, I've got a product here, so this is 5 plus log base b of 3 to the 1/2 minus, now this is my quotient, log base b of 2. Last thing I have to do here is I can pull this 1/2 out, so this is going to all equal log base b of 5 plus 1/2 log base b of 3 minus log base b of 2. And it looks like I'm running out of room here, but I think I might be ready to call this thing quits. This is all going to equal log base b of 5 is r, so this is r plus 1/2 of log base b of 3, which is q, minus log base b of 2, which is p. So all of this is what I get when I write this in terms of p, q, and r. So using those same definitions of p, q, and r, why don't you try this example? Try and make these numbers as some sort of product or quotient or something to do with 2's and 3's and 5's. Pause the video, give it a shot. All right, and here's my work for those two problems. Hopefully you were able to get something like that. And we're going to see some more examples in the next video.